Hello, everyone, and welcome back to our next episode of Big Data Talks, in which we have conversations with industry experts about the ways in which data, machine learning, and artificial intelligence are changing the way we live. My name is Jan-Willem Middelburg, and I will be your host today. I'm the author of the Enterprise Big Data Framework, which is hosting this series of Big Data Talks. You can always watch back the recordings and of this discussion back on YouTube, the Big Data Framework website, and the podcasting platform on Apple Podcasts. Today, I'm very happy to announce my next guest, Dr. Akhil Sahai. Dr. Akil is a founding member of Kanverse and is an accomplished executive with more than 20 years of extensive experience of managing high-growth, multi-million-dollar, hundreds-of-dollar company portfolios across large companies, such as LexisNexis, HP, Dell, Cisco, and VMware. Currently, he's heavily involved in the way of scaled startups. Dr. Akil has a Ph.D. from INRIA France and an MBA from Wharton School. He has 17 different technical patents and has authored a book and 80+ technical peer-reviewed articles. I have had the great pleasure of meeting Dr. Akil a couple of years ago in person when we met in Kuala Lumpur. And I still remember his talk on machine learning and AI, which really inspired me at the time. It is such a great pleasure to talk to you again, Dr. Akil, and welcome to Big Data Talks.
Thank you, Jan. It's really a great pleasure to see you again and talk to you.
Absolutely. So just to get started a little bit, I still remember the days very vividly from 2 years ago. The first time I met you, you were the Chief Product Officer at Symphony SummitAI. And today you joined a startup, Kanverse, which started in 2020. Can you tell me a little bit more about this company and the product that you are creating?
Sure. So Kanverse AI is a hyper automation company, and the products that we build are built on top of a hyper automation platform, and we're building a suite of products, right? And our flagship product is called the Intelligent Document Processing product, and the idea here is to apply AI and machine learning to digitize all the document processing heavy workflows in enterprises, right? And if you see, across enterprises, whether it's horizontal functions like marketing, HR, finance, and accounting, or whether it's verticals like insurance, banking, finance, these are very document processing heavy workflows. So we are trying to digitize all that using AI and machine learning.
Good. And do I then need to think about an advanced version of, let's say, OCR technology?
So OCR is, one of the basic technologies, that you have to have. But then what we are doing is we are taking OCR and we are applying 7 different technologies to it, right? So like multiple machine learning and AI technologies like computer vision, fuzzy logic, machine learning, and of course, natural language processing. And to get to that really high extraction accuracy, and then we add workflows and automation technologies to it in terms of business logic framework that helps us do an end-to-end automation.
Wow, that sounds indeed a much more of an advanced version. So you started this company, I would say, in the height or the middle of the pandemic, which was a very difficult time for everyone across the world. Was this not a very difficult moment to start a startup, especially to get funding and to get the traction for a new company?
Yeah, no, so this is actually a great question. So pandemic actually helped us in a big way because pandemic forced people to digitize their workflows and not have humans touching documents or entering manually things, right? So effectively, there was a need for collaboration. There was a need for distributed handling of documents, working in teams, and effectively removing the bottlenecks around manual processing. And so that kind of gave us a push in terms of digitizing the workflows. And so this was actually a good thing in a way. Of course, a pandemic was bad for everyone, but then, in a way, it helped propel this digital transformation in enterprises. That was the calling for Kanverse.
Well, it's actually good to hear that there's also been some positive effects of the pandemic. I'm very glad to hear that. Because most businesses have been struggling. But I agree with the whole digitalization that might have been a very good push to start a company. As you see, and we talked about this beforehand, you know that this series is all around big data, machine learning, and AI, and that's also why I specifically wanted to have you as a guest on this show. Can you tell me a little bit more? You already mentioned about some of the machine learning elements, but which specific technologies are embedded within Kanverse that makes it so highly effective?
Yeah, no, so Kanverse, of course, uses OCR as a base technology like we talked about. And then, it has a multi-stage AI engine, which is patent pending, and that uses like the 4 different technologies that I talked about. So computer vision, which is, used in self-driving cars, and we use that for recognizing patterns and blocks. And then using fuzzy logic, we're able to clean all this data, and we apply natural language processing to understand the semantics of what we have extracted and ontologies, and, and matching it with dictionary of terms. And then we apply machine learning to detect patterns, right, and anomalies. So that all actually helps a lot in terms of high extraction accuracy, but also detecting things like fraud, potentially that could be happening, or error analytics. And then we combine that with workflows and business tool engine to actually do this end-to-end validation and filing of documents.
That's very interesting. So most of the listeners on this show are, I would say, a little bit in depth into the technology, like myself. I love diving into the dynamics of how algorithms are composed. If I were to ask to go one level deeper beyond some of the techniques you just mentioned, what are some of the I would say, basic algorithms that are used in order to accomplish this?
Yeah, so there's a lot of algorithms that we've implemented, which to get this done effectively. But among the algorithms that I've used, in the past as well as in the product today, I really like some algorithms which are simple, right? Like an example would be the Mahalanobis algorithm, right, which is really about finding the smallest distance, from a distribution, right, of a point. So those are really great algorithms for anomaly detection, effectively, right? So, that's one of the algorithms that we've looked at. Of course, there's a whole bunch of them out there, that helps you get this done.
Yeah, absolutely. So one of my favorite questions that I typically ask all of our guests is, and it doesn't have to be related to Kanverse, but do you have a favorite algorithm? And if so, which one is it and why?
Yeah, no, that's actually exactly what I talked about, the Mahalanobis algorithm, because it's done by an Indian scientist called P.C. Mahalanobis, and I really admire how he thought of such a interesting, complex concept in such a simple way, right? In terms of finding the distance of a point from a distribution, effectively gives you a very easy way of finding anomalies, and that's really fundamental to finding anomalies in large data sets, right? And especially multi-dimensional data sets. So this is one of my favorite algorithms, yes.
That's very interesting, and it's very nice and also quite exciting to hear that there's and this algorithm has not been mentioned on any of the previous episodes, so I'm pretty sure a lot of people are going to now dive into it right away. Mm-hmm. Good. So the second section that I want to get your experience a little bit more is you've been involved in a variety of different capacities over your career, but there's always a very central element, and that is the development of IT products specifically. So today you are the chief product officer. I'm assuming you're responsible for all of the major technical decisions of the design of the platform. When you build a new platform for a startup like you're doing today, where do you begin?
Yeah, no, that's actually a great question. So as a chief product officer or as a product manager, you need to be very data driven, right? So you need to look at the data, and the data could be coming from customers, that could be coming from experts, could be from analysts, and even the data that you might have collected, from other efforts that you might have done. So effectively, bringing together all this data and inputs helps you identify an opportunity and its market size, and and the competitive landscape, right? To understand that is extremely important to identify what you want to do, right? As whether you're building a new product completely from scratch, or whether you are developing a product further, to be differentiated in the market. So you need to do all this research, actually to be very data driven, and that's what I, as a product manager and a CPO, do, right? And of course, work with my team to actually build the best product that is unique and differentiated, but it has to be very data driven.
Yeah, absolutely. So one of the things that you mentioned really triggers my mind, and that's the competitive landscape. Because I assume you're based in the Bay Area, there's so many creative companies nowadays with so many great ideas. And I would also say that there's probably a lot of competition, especially in that domain. You have a wealth and a very long history and a great amount of experience. So what was it in this product in Kanverse that was what interested you right away? Because you could have worked on so many different things. What is it that made this one so special?
Yeah, so there are multiple reasons why Kanverse, right? So of course, there is a potential to transform enterprise business processes, right? And the big impact that it can have. But then more importantly, it's really how you build the product and what's new about it, right? Like you're saying, there's so many products out there. How do you be differentiated and competitive and unique, right? And the reason why we believe we are unique is because of how we brought together multiple technologies to bear upon this problem, right? And to be on the cutting edge, you have to be out innovating the competition, right? So that is extremely important. You always have to be on your toes. You always have to be, the next big thing. You have to bring that to the market. And that's what is my mantra. And of course, I try to work with my team to kind of get that, cutting edge work done, right? And so that you need to continuously do, but also is because it's a confluence of multiple ideas and systems, right? So you need to be building a product that's scalable. You can handle hundreds and thousands of documents coming in. So it has to be a huge cloud computing aware product that is, multi-tenant and SaaS, so all the systems knowledge. And then the AI and the technologies that we talked about, right? All this comes together to build a great product like Kanverse, right? So the confluence and the unique mix that it has is very interesting.
Yeah. So would you say that it's kind of the culmination of your experience over the last few years?
I would say definitely, builds upon my strengths and my experience. Of course, we'll continue to build, and develop. But yeah, definitely leverages a lot of my experience. Yeah.
Good. So I'm always very interested in my work. I'm also a lot involved with product development. So are you using a particular development methodology at Kanverse? And if so, what is it? And how do you decide on some of the best practices to develop these kinds of products?
Yeah, so we are definitely very agile in our methodology and in our thinking, and not just for development, but also for product management, right? So, and for marketing, right? So basically you need to be working off a backlog, right? Like you do typically in an agile methodology. And we are always updating that based on the market, based on the competition, based on what we're seeing as feedback from the customers. And then not only just maintaining the backlog, but actually being on the cutting edge to be developing this every 2 weeks, in sprints of 2 weeks, and releasing the product every 2 to 3 months, right? So based on that, we need to be continuously innovating. And we also do hot fixes, right? If the customer requirements are really interesting and generic, we do hot fixes as well. So it's about agile development, but maintaining the balance is also very important, right? So depending on the kind of product you're building, a release cycle would make sense, right? In our case, we have identified this kind of release cycle for agile methodology.
Very, very interesting, because I'm very happy to hear that agile is still, I would say, the approach you're recommending. That's also the approach that we're using in our company. So I'm still happy to hear that I'm quite up to date in that regard.
Yes.
Good. Dr. Akil, you've been in the IT and product development for many, many years. One of the main questions I kind of wanted to touch upon for other listeners is, how do you get towards becoming a chief product officer? I noticed that you studied at Penn. I also did, so we're from the same school. That's where you focused really on an MBA, so that's more towards the business side of things, so not so much towards the technology. So if there's people who are listening today that have a strong ambition to become a chief product officer as well in a number of years or in their career, what is the path that you recommend people to follow?
Yeah, so that was, of course, a very interesting journey, right? So as you mentioned, so I've been in technology, I was a technologist, did my PhD, I was in HP Labs for a while, where we were doing a lot of research into the latest and greatest. And then I went and did my MBA at UPenn, and that kind of did have a transformational effect on not only my thinking, but also in terms of how it opened up opportunities for me. And I moved into product management into VMware, and my products that I managed were really very interesting. I managed a vCloud product, and that gave me a place to learn and grow as a product manager, right? And then of course there was no looking back after that. So that was definitely transformational, a bend in the in my career, and I think it landed me into a sweet spot, which I feel is my strength, where I bring my business expertise and acumen as well as my technical background and knowledge, and I'm able to meld that. So for someone who's trying to go down the same path, you don't necessarily have to go do an MBA. It does help often to kind of give you more opportunities that you probably would not have otherwise. But you can also do a lot of self-learning. You can do a lot of building, whether it's about you're working on a startup where you end up doing a lot of things yourself as a technologist. You do a lot of product management, you do a lot of marketing yourself, and that is a really great learning exercise in terms of building a startup or participating in one and learning on the job, right? I mean, so that definitely helps, right? So there's no, I would say, a direct path to becoming a CPO, but you need to keep your eyes open, keep learning. Think about being data driven every time you make a decision about a product being built. And that, I think, are building blocks. And of course, the methodology and the processes you can always learn, right? And you learn them, from books, you can learn them from other experts, and, find a mentor if you can, who can help you guide as well on your path, to being a CPO.
Absolutely. So it's very interesting to hear you say that your educational journey was transformational, as you put it. Would you say that the red thread is education?
So in my case, it was, but it doesn't have to be, right? I mean, so what I'm saying is a lot of people, learn on their own and on the job, and that's perfectly fine. You can definitely, get there, without getting extra education.
Yeah. Speaking about learning and probably also very much coupled with innovation, I saw that you have 17 different patents on your name. Can you tell me a little bit more about this and what kind of inventions have you made over the last few years?
Yeah, so a lot of my patents are on distributed systems and on, on service management, on effectively a lot on utility computing, cloud computing, so the work that we were doing before cloud, took shape. And so a lot of the patents are on those areas, especially around distributed systems are really interesting ones. A lot of new ones are around, document processing, around application of AI. In the last 3 or 4 different roles that I've had, I've driven a lot of product lines and portfolios where the AI and ML were really ever present. So a lot of the patents have actually come out of that as well.
Very, very interesting. I think that's it's always a major accomplishment when you see that some of your thought leadership and your work is actually recognized in the industry in the form of a patent. One of the other things you do, and I'm pretty sure it's very much related, is you do a lot of writing, including books. I found dozens of articles by your name. As you probably know from the days that we met, I also try to write on a very consistent basis. So I just kind of wanted to pick your brain a little bit on what is your process? Where do you find the time, first of all, to publish new things, but also how do you do your research on deciding, this is something I want to really dive into and, for instance, write an article or some kind of a publication around?
Yeah, no, so it's very important to not only learn and drive and do great things, but also to pass that knowledge on to a broader audience, right? To understand how this could help others, and so that's why I do try to write things down, whether it's research articles or whether it's techno marketing articles that I write a lot nowadays. Also, just to make it kind of understandable and break it down into simpler terms, so it's easier reads, right? So effectively, it's very important to pass that knowledge to broader audience, and I try to do that a lot. And it's difficult to find that time, but I typically allocate some time to do that always. And I know you also write a lot, so we really need to do this, right, to kind of pass that knowledge out and help kind of the broader audience.
Yeah, what you're saying is a very valid point. I always need to kind of lock myself away in a room for a couple of hours because there's always so many distractions going on. So to really start diving into it and write something, yeah, it's a bit of a process. The thing that I find really inspiring, and that might already be the key lesson to learn from this episode, is the need to kind of share knowledge. And I think that is really also one of the big elements of how you build reputation and get more knowledge out there in the world. So that's a very inspiring part. One of the other main topics, because I think I now have a bit of a better understanding around the product development part, but one of the other main topics I wanted to talk to you about is, I would say, is diving one step deeper and discussing a little bit more on the technical side, especially on algorithms. Mm-hmm. As we've already seen, one of the core objectives of this podcast is to provide people with a more beyond basic level understanding around big data and AI. These are two very big buzzwords, so it's always, in my opinion, very important to break this down a little bit more into some more practical aspects. So if it's okay with you, I would like to ask you some more in-depth questions. I'm taking into account that not all our listeners will have PhDs, so I'm not going to make it too complicated, but I do want to actually ask you some more in-depth questions around some of the work that you've been doing. And in preparation for this show, what I read is I started to read some of your articles and especially some of your research that is all published online, so everyone who's listening today can also find this without just Googling it. And one of the things one of the articles that I found, that I personally found very interesting was called A Mechanism of Specifying and Determining Pricing in Utility Computing Environments. So in other words, how can you determine pricing for utility computing? And I assume that you mean cloud with that. Can you tell me a little bit more about this specific area of research?
Yeah, no, so this was actually a very interesting piece of work that we did on utility computing, which was a precursor to cloud computing, right? So utility computing was all about using computing as a utility, just like you would use water and electricity, you would use computing, and effectively cloud computing is that, right? So it's about using cloud resources as you go, right? And so the pricing model that we came out was a continuous pricing model where we had this notion of a computon, and effectively you can price based on that. And as you use more and more power, you would basically pay more for more computons and effectively pay more, right? So which was very interesting because when you see cloud computing and how they price resources, it's also on similar lines, right? They have the small, medium, large units of computing, and networking and storage, and that you can pay as you go, right? Effectively, and you can upgrade, and so it's not completely continuous, but it's still discrete, in terms of unit, right? So it's very similar in terms of pricing based on unit and pay as you go model, which was discussed in this paper. It's about 20 years ago now. Yeah.
What was it? What you would say is this the steps probably before we launched cloud computing as we now know it today. So was this the leading up stage towards it?
Yes, exactly. So this was actually HP's project around utility computing. So we were creating this utility data center, which was about taking data centers and making them into utilities, so it can have a programmatic API, and you can actually get resources on demand. So this was actually your private cloud. Then when I joined VMware, that's when vCloud started taking effect, right? And vCloud was the premier product in cloud computing. And this utility computing work was really fed into that. And effectively, this whole idea of having computing as utility was the building block for cloud computing. So I would say it was pretty early adaptation of pricing models and the work that happened eventually in the cloud.
It's very, very interesting because, and this is also the reason I specifically picked this article. One of the big trends that you're seeing is that we're getting more and more into a mindset in which we're using everything as a utility. And we've seen it with houses, we've seen it with vacations, we now see it a lot with transportation. If you think back around that adaptive pricing model that you created, would you say that it is also going to be applicable for other industries or other specific areas that are moving more towards utility-based?
Yeah, I think you brought that up, in terms of how it could be applicable to other industries too, right? I mean, this notion of pay-as-you-go is actually very exciting, right? It could be, for example, when you do rentals, right, and you basically want to, pay as much as you use, right? And that is a similar kind of model, right? Whether you are talking about renting housing, right? So it's basically, this model is applicable, right? This utility pricing is very attractive. And so I'm assuming as we go, this will become more and more prevalent, right? Definitely cloud has adopted it, lock, stock and barrel, right? So I'm hoping this will happen across the board.
Correct. That's really good to hear. I know that there's always the part, writing papers like this, and there's always a bit of a disparity with the actual world. So one of the things I'm also really always interested in with research, and especially research paper, is was this model actually implemented? So are there cloud providers today or utility providers today that are actually making use of this patent or this paper and the algorithm that you've developed?
Yeah, so I think if you look at cloud pricing models today, they definitely are using something similar, right? So they have this notion of discrete pricing, as I talked about. So you have this units of small, medium, large, and you can actually purchase them. You can upgrade them. You can shut them down if you're not using it. You don't have to pay for them if you're not using them. So that's really definitely a pay-as-you-go model. And also, if you think deeply, it's actually a notion of a compute on, right? Effectively, you have different units that you can buy at different prices. So, this is actually kind of very interesting because this model seems to have helped, right, in terms of coming up with these new models.
Yeah, and how cool is it that you build something that has actually helped move this industry forward? One of the other articles that I came across that really caught my attention, and that's because I've been very heavily involved in the last 2 years, especially when it comes towards artificial intelligence and getting a better understanding of how that works and what are the algorithms that are powering that. And the article that you published was called a performance evaluation of backpropagation neural network implementations on single program multiple data architectures, which are known as SPMD architectures. I read it, I tried to really comprehend it, but I have to say it was kind of a bit of a more complex paper, but obviously that makes it all the more interesting. For our listeners who might not be very well versed in what neural networks are or SPMDs, could you explain maybe in very layman's terms what is a neural network and what was the key topic of this paper?
Yeah, no, so single program multiple data is a way of programming in parallel computers, parallel processing computers, right? And so this was implemented on India's supercomputer called Param. And basically it has multiple nodes. And what we did was we programmed the backpropagation neural network on that parallel processing computer, right? So effectively, what happens is every time a node comes alive, it sees which part of the neural network it is, and it will take its position accordingly, right? It will take the inputs and process it accordingly. So effectively, you can convert a really complex backpropagation neural network on top of a parallel processing computer, supercomputer in this case, and you can parse inputs and do very quick recognition. And this was applied to defense in terms of aircraft recognition, right? So that was the use case that we had worked with. So the idea of a neural network, of course, is very simple, right? It's, this is a 20-year-old paper. So effectively, which is still, very relevant today, right? Because, a lot of deep learning algorithms are based out of subcategories of neural networks, right? So the backpropagation neural networks effectively are a set of neurons that are connected through inputs and output, information paths. And they are supposed to, in simple terms, replicate the human brain, right? Where human neurons are the nodes, and then, the connections effectively that are formed between neurons are the input and output that goes into each of them. And based on certain inputs, you'll create an output, right? So assuming you're trying to recognize a cat or a dog, you look at various features of the cat and the dog, its height, its face, the amount of body hair potentially, and the sound and things like that. And you'll say it's a cat or a dog, right? So effectively, that's what a neural network does in your brain. And that's what an artificial neural network would do, right? In terms of taking inputs and creating an output.
Yeah, absolutely. And even though this is indeed a concept that's been around for a long time, 20 years you mentioned, I think it's still very relevant and maybe is even becoming more and more interesting as we see more applications of AI especially in the enterprise world. Mm-hmm. One of the things you mentioned that I thought very interesting, so you did this on parallel computing, and you mentioned it was used specifically for an aviation use case. So mm-hmm. Does that mean detecting kind of the make and model of a plane, or just the fact that there is a plane approaching? Okay, can you elaborate a little bit more on that?
Yeah, it was both actually. It was about the model of the aircraft and how far it is, right, in terms of the inputs that you're receiving. And effectively, this had a defense use case where you're trying to identify, whether it's a friendly aircraft or an enemy aircraft, and so you can do a lot with that. Yeah.
So in terms of a last question around this is in terms of accuracy on that detection. So determining whether it's, let's say, a commercial airline or a fighter jet or something like that. What were the results in terms of the result? Could we predict with this algorithm for, let's say, 95% that it's accurate, or can you elaborate a little bit on that?
Yeah, so this algorithm actually turned out to be pretty accurate, I think we got up to 93 to 94% accuracy. It's pretty good, with the amount of work that we did. And of course, it was transferred to the defense organization to kind of develop this further and take it into defense systems. But, this was very exciting because we were able to get to apply AI and machine learning in this case to a use case that was very common, right, and very practical, I would say.
Yeah, so I think it's a very cool topic, and it's definitely something I can probably spend the rest of the day talking with you about, because the way that you explain it's something that's so complex, so tremendously easily. One of the next questions I'd like to ask is, in one of my previous episodes, I had a very interesting discussion with Abhijit Duda, who's the Director of Big Data and AI at Globant. It's one of the larger companies who builds big data solutions. And our conversation kind of wandered into one very specific element. We got into a discussion around what are skills that are relevant for the future. So if you were to pick any choose of study, again, suppose that you're young again and you're 18 years old, and you would need to study, you can study anything you want. And the subject that he chose was, if I were 18 again, I would just start out in this world, I would choose quantum physics, because I really think that that is going to change the world. If I were to ask you the same question, if you were 18 again today and you would need to pick any kind of subject, it doesn't have to be IT related or anything, but if you can start with a blank slate, what would you choose to study, and especially why?
So that's, of course, a very exciting question and a very interesting one at that, right? I mean, there's, of course, I would like to study a lot, when if I could become young again. Of course, things that I see that could have helped really if I had learned them earlier was, of course, data science, right? And that, early on, would have really given me that grounding that I, of course, picked up over the years, right? And that I would have definitely learned. The other things that are exciting beyond IT are things like genomics, right? I would think that it has a huge potential to change how we live, address aging, all these things that human race has struggled with and is still struggling, right? In terms of reversing aging, identifying, why we have these kind of diseases that we have, effectively applying AI and machine learning to that would be wonderful, right? In terms of taking it to the next level.
Absolutely, and it's interesting that you picked those two because in the last 2 years I've actually been doing this master's program in which I'm also focusing a lot again on learning AI and big data topics. And one of the use cases that you very frequently see, especially when it comes to data science, is indeed these genomics databases, because they're very open, so almost every student can look them up and do research, but also because it's so tremendously complex. So I would even say, to go as far to say that the field of genomics and maybe biology as we know it is becoming more of a data-driven and maybe even data science domain. And it's also something I've been seeing a lot in other industries. I think if we think about banking, aviation, insurance, you see that all of these highly volume data companies are becoming way more data-driven, and that data science is becoming one of the main elements to make decisions towards the future. Is this a pattern you recognize and that you're seeing in your part of the world as well?
Yeah, no, I think you hit the nail on the head. So this is, really where the next set of innovations are going to happen, right? It's really where data science is at the cross-section of biology or genomics and data science and AI, right? It's really where all the innovations are going to happen, right? And so it's a whole new area opening up, right? In terms of, all the things that you can think of, right? Identifying genes that cause diseases, reversing aging, all these things, great things that, a human race has to address, right? And we need to address.
Yeah. I think if we could use data science to solve some of the more pressing problems in the world, then that would actually really take us a couple of steps forward.
Yeah.
As part of the series, and you've kind of seen this is also a little bit of the red thread that I'm using throughout these interviews, is I'm always very focused on learning, ensuring that people learn new skills. Hopefully this podcast also inspires them to start reading up on the algorithms that you mentioned, or to kind of start reading your papers. One of the main things that I do really see out there is that there's still gaps in terms of the knowledge that people need versus the knowledge that's being taught in schools, universities. What is your view on this, and what would be some of the major gaps that you see that would need to be addressed?
So, of course, universities are doing their bit in terms of passing structured information, but I think a lot has to be done to actually fill the gaps, right? And that, could be from, picking it up through your experiences by kind of doing a lot of hands-on work in terms of building things, working with and talking to experts who have built the tribal knowledge, as you call it, right, over the years. So tapping into experts, tapping into, listening to them as well as reading from them and talking to them. You'll basically be able to fill a lot of that information. And of course, seek out, different sources of data and information, right? Whether it's, publications which are not necessarily potentially captured in the universities or education systems, but are available to you. And a lot of information is actually put online nowadays, so you can gather that information from there. So effectively fill the gap from wherever you can, and that is essential to kind of have that complete knowledge that you need to actually get things done.
Absolutely, I fully agree with you. As long as you're curious and there's so much resources out there, if you trigger yourself to kind of fill that gap, because that gap is there, if you take some effort by yourself, I do think it's something you could address relatively simply, because there's such a tremendous trove of information available nowadays.
Yep.
We're slowly getting towards the end of our time together, so I'd like to ask you one last question. We recently launched with the Enterprise Big Data Framework an ambassador program to kind of build a community of experts around the world that are considered the thought leaders in terms of big data. Based on our conversations, I would be very honored if you would like to join the program. Will you accept my invitation?
Of course, of course I'll be happy to do that.
Great. You'll be our first ambassador in the US, so I'm actually quite happy that you would like to do that and promote people to learn more around big data and especially machine learning and AI. We're slowly getting towards the end of our time, so thank you so much, Dr. Akil, for participating in what I think is, again, a very interesting episode of Big Data Talks. From my side, it's been an absolute pleasure to catch up with you. I know it's been almost 2 years since we last spoke in person, and your great words of wisdom are really appreciated. I sincerely hope it inspires others to think differently around the way in which data is changing the world, and also hope that it inspires people to start reading around your research and articles and to learn something new about algorithms and the way in which big data is changing the world. Thank you so much for your time, Dr. Akil.
Thank you, Jan. It's been a pleasure.